Math gives you power to find the answers. Last Wednesday night, about 11:30 p.m., I saw this Facebook posting from my friend Sean needing some help with an algebra problem. Sean and his wife Heidi are a great young couple I know from my church who do a lot to help me and my family in ways I can only begin to explain. But what really interested me in addition to wanting to help my friend was the challenge of problem solving, and I thought that creating a model using algebra was something I could possibly do. I noticed that before my first response to his request, there had been at least 4 other friends helping him. I say at least because there may have been others that I didn't even know about. Sean later thought it might be helpful, and I agree with him, that it's useful to understand that we are talking about a real-world use of algebra. Sean is a consultant for a well-known consulting firm. Sean represents his firm by helping his client, in this case an oil and gas operations company, who is considering going into deep-water oil drilling. This formula he was seeking is helping to model his client's costs. This is the first thing I did. I constructed a data set to model the situation. In fact, this is a picture of my actual handwriting of the data. The starting production amount is in the left column and the corresponding cost of production is in the right column. I picked 1,100 as initial input-output values, so the subsequent arithmetic should be pretty easy, especially 100, which would be essentially a starting cost of 100%. The next 2 points, 2,80 and 4,64, were easy to do in my head. For the next 3 points, 8,52.2, 16, 40.96, and 32, 32.768, I used a calculator to find the exact outputs. I got out my TI-84 Plus graphic calculator. Going to Stat Edit, I entered the points under the columns L1 and L2. You can see all the data entered from my initial writing. Next, I went to see the data plotted by first going to y equals to see that plot 1 was turned on. Then to view the data, I went to Zoom 9, which is otherwise stated as Zoom Stat. To me, this looks kind of like an exponential relation, which makes sense given the percentage reduction. I have often used depreciation curves that look a lot like this for automobile depreciation and even for, coincidentally, oil and gas production declines. So I went to Stat, then Calc. Next, I scrolled down to the exponential regression, which is option number 0. Next, I pressed Enter. We see that L1 is a X list and L2 the Y list, which comes from my handwritten data. I scrolled down to calculate, then pressed Enter. We get the equation y equals 80 times 0.9686, etc. to the power of x as our calculated exponential equation. And here is the equation pasted into the function editor. The whole function is pasted there, even though we don't see the last part of it here in the view screen window. Press Graph. We see that we don't have a very good fit for the points. Next, we're going to the catalog view to turn diagnostic on. Press Enter twice. This diagnostic tool gives us the accuracy of correlation by calculating the difference between the equation and the data input points using the least squares method. Next, we'll go back to Stat Calc, but this time we'll scroll down to option A, which is power regression. Press Enter. Go down to Calculate. Press Enter again. This is what we get. Y equals x to the power of negative 0.3219280,949. Note the r squared of 1 and the r value of negative 1. These are the diagnostic values indicating perfect correlation with the data. Now we go to paste this equation into the function editor. Press Graph. We see that the data seem to fit the points precisely, which is not surprising since we had our r squared and r values of 1 and negative 1 respectively. Then, as a matter of curiosity, I went back and redid the exponential regression using the data to see what the diagnostics would tell us. We see that an r squared value of about 0.82, a definite indicator of some correlation, but not nearly a perfect correlation. I initially thought that because of the 20% decrease in just looking at the graph of the points that an exponential relation was most likely the best fit. But in this instance, because there was an exponential increase for both the input and output values simultaneously, the net effect required a power regression, which is a less common modeling relation, by my experience at least. More specifically, Sean wanted to know the cost at a 35% increase over the initial production amount. And this is where I found it in the calculator. But changing the table set increments, I changed them to 0.01, then I went to the table view to 1.35. At this input value of 1.35, we get a production cost of 90.791, meaning nearly 91% of the original cost. This is the way I answered Sean after having found the equation. Sean thanked me for my help. I told him I was glad I could help. I made this presentation as a case in point of the title of my new YouTube channel and soon-to-be functioning website, Math Gives You Power. This presentation is specifically about math giving you the power to find answers. When you have the ability to find answers, you can help people. And sometimes it will be helpful when you least expect it. For me specifically, it was my experience modeling real-world situations with different types of equations that set me down the path of being able to solve this real-world problem. I also want to assure you that I'm not the only one who comes up with answers. Sometimes, to help me, it's other teachers, maybe teachers on YouTube. Sometimes it's other YouTube viewers. Sometimes even my own public school students come up with the answers, techniques, and approaches that benefit me. I had a student, Alex, help me with synthetic division. And if I were to make a call out to my Facebook friends, like Sean did, I'm sure Sean and many others would chime in and would be successful in helping me. This has been Math Gives You Power to Find the Answers. Thanks for viewing.